Webb just saw the farthest star ever, and it is mind-blowing. The farthest single star in history has just been spotted by the Hubble Space Telescope, according to a recent announcement. This incredible discovery was made with the help of one of the most potent telescopes, James Webb Telescope, and it is a little chance of luck to spot such a star. James Webb recently witnessed the most distant star, and it was astounding and mind-blowing. In just a few weeks of operation, the James Webb Space Telescope has signaled the commencement of a brand new era in extragalactic astronomy. A variety of potential galaxies that contradict the current theories of galactic development have already been found by the infrared telescope, Hubble Space. Webb turned its detectors towards Earendel, the universe's greatest remote and solitary star, and beheld fantastic images. Many scientists didn't anticipate the Hubble Space Telescope to be able to do this. They say one can make out a star, either an individual star or a pair of stars, but it is so distant apart. But the pictures of this kind of take your breath away. It took the light roughly 13 billion years to reach us, perhaps a little less time, closer to 12.9 billion years. This is astounding when you take into account that the stars we are seeing date from the very early universe. It is likely one of the first generations of stars to have ever existed, and this is the reason we can see a single star this far away thanks to this lovely pure chance. In other words, there is a massive cluster of galaxies that is closer to us than the star and is positioned around our galaxy. These galaxies, of course, contain hundreds of billions of stars. The idea that gravity causes space and time to bend dates back to Albert Einstein. Therefore, this nearby galaxy cluster is stretching and creating space around it, creating a unique glass formed of space and time. As a result, space is being bent from this nearby galaxy cluster back to much farther into the past. It's only a coincidence that this particular star aligns perfectly with the lens, resulting in 1,000-fold magnification. Therefore, gravitational lensing, a marvelous natural effect and an intriguing phenomenon, is the reason Hubble can even view this star. You might be interested in knowing the distance of how light travels. The light travel proximity to Earendel is 12.9 billion light-years, which means that the star emerged when the galaxy was many years old. The infrared telescope has already found several candidate galaxies, and Earendel might be a member of a specialized group of stars that astronomers have been looking for more than 50 years. You may have been asking yourself some important questions, such as, how can a single star be found in a distant universe? What distinguishes Earendel, the morning star or rising star or dawn, from the stars we see now? And how do the new Earendel James Webb discoveries affect our understanding of galaxy formation? Well, the distance to Earendel by interstellar travel is 12.9 billion light-years from Earth, but the actual distance, which takes the universe's expansion into account, is 28 billion light-years from Earth. So in reality, we are viewing the star as it was many years ago. The Sun and the Earth indicate that Earendel is old. Star clusters ensconced in far-off galaxies have thus far been the tiniest objects discovered at these distances. However, Earendel is the first lone star discovered at such a great distance. By coincidence, the Hubble Space Telescope stumbled upon this star. The star's parental galaxy, which was gravitationally lensed by a cluster in the foreground, was initially discovered by the Hubble Space Telescope. Galaxy clusters and other large astronomical bodies bend the fabric of space and time around them. This displacement results from the light of the foreground astronomical objects bending as it approaches these enormous objects. The foreground clusters can magnify the light from individual stars thousands of times in certain circumstances of exact alignment. The sunrise arc was given by the scientists to describe how the background galaxy that contained Earendel appeared as a result of gravitational lensing. However, the scientists noticed a brilliant object resting on the twisted galaxy's edge. The majority of bright sources in far-off galaxies are often extremely energetic phenomena like novas, supernovae, or tidal disruptions by black holes. These are transient, meaning their brightness will fluctuate over time. The brightness of this object, however, stayed steady for more than 3.5 years, according to Hubble's observations. The bright star is gravitationally lensed in the sunrise arc, according to the findings of scientists. Hubble's wavelength restrictions prevented it from learning much about this far-off star. To learn more about Earendel's characteristics, researchers employed the James Webb Space Telescope. Dr. Brian Welsh from Johns Hopkins University, who was the study's principal investigator. In March 2022, he and his team used data from the Hubble Space Telescope to find a star. The researchers used Webb's NIRCam sensor to capture fresh photographs of Earendel, which they then evaluated in their report. The wavelength in these pictures ranged from 0.8 to 5 microns. 8 distinct Webb filters, each with an exposure length of more than 30 minutes, were used to study Earendel. The location of Earendel is confirmed by new Webb measurements to be a 6.2 redshift. The Hubble Space Telescope measurements from early 2022 agree with this figure, making Earendel the greatest possible star discovered. The star's bolometric brilliance, or the amount of radiation it emits across the whole electromagnetic spectrum, is the next critical aspect to consider. According to the Webb observations, Earendel cannot be a low-mass stellar brown dwarf or a free-floating exoplanet that underwent gravitational lensing. The information indicates that it is a B-type star with a surface temperature of 13,000 to 16,000 Kelvin. According to their surface temperatures, stars in the cosmos can be broadly classified into 7 groups: O, B, A, F, G, K, and M. The sequence can be remembered using a famous mnemonic. The issue arises when we calculate Earendel's overall luminance, which ranges from 600,000 to 1 million times that of the Sun. If Earendel is a single evolved star, its mass must be approximately 40 times the size of the Sun. If the surface temperature of roughly 15,000 Kelvin is assumed, this light may be produced by 2 stars of 30 solar masses or 5 stars of 20 solar masses. The researchers stress in their report that a single star solution is not the only one that may explain the spectral energy distribution graphs, which is why the potential that Earendel is a multiple star system should not be dismissed. Massive stars that we observe in our immediate environment frequently have companions, sometimes more than one. Even if Earendel contains companion stars, the James Webb Telescope's resolution power prevents it from seeing them, since the tertiary companions can be as far away from the star as 20 astronomical units, and the primary companions are within 2 astronomical units of the star. The Humphreys-Davidson restriction, sometimes known as the HD point of confinement, will be exceeded if the star is 1 million times more brilliant than the Sun. The HD restriction is the empirical luminance limit, at least in the nearby universe, above which no stars have been seen. Therefore, we may need to re-evaluate the HD restriction and set new limitations on it if Earendel is verified to be a single star with 1 million times the luminosity of the Sun. The discovery of Earendel is significant because it may be the first sighting of a population 3 star, which astronomers had been searching for a long time. Helium and hydrogen are the 2 principal chemical elements created during primordial nucleosynthesis. Population 3 stars, the earliest generation of stars, had a low metallicity since they only contain trace amounts of metal. Any elements that isn't hydrogen or helium is referred to as a metal in astronomy. The majority of population 3 stars, according to astronomers, have already died, and the ones that are still around are quite faint and challenging to view. The majority of candidates have been discovered in gravitationally lensed galaxies since they are practically hard to observe naturally. For many years to the future, astronomers anticipate that Earendel will continue to be magnified greatly. The next James Webb Space Telescope observation of Earendel is planned for December 2022. The kind and stage of Earendel's stellar lifetime could be determined by precise measurements of its brightness and surface temperature. Additionally, Astronomers anticipate finding that the Sunrise Arc galaxy lacks the heavy elements that develop in succeeding star generations. It would betray Earendel's status as a rare, huge, and metal-poor star. Finding the first stars and galaxies has long been considered a jewel in the crown in astronomy. The discovery of the first generation of stars would help us comprehend star creation and validate the forecasts. Furthermore, looking for them is similar to looking for our historical roots, because the most amazing finding in all astronomy is that the stars are composed of atoms of the same kind as those on Earth.